Hello, students and fellow researchers. I am going to discuss the limitation of ANOVA as a test of significance. The most used test of significance of difference between two groups or samples is t-test. For three or more groups, ANOVA is employed, but is a significant difference result arising from ANOVA sufficient? In multi-samples, there are three or more pairs, not just one pair, as in the case of t-test. Does a significant difference in ANOVA mean that a significant difference exists in each of the three or more pairs in a multi-sample study? To better understand this, let us consider the following multi-sample differential study. Professor of Statistics is conducting a study on the possible effect of love life status on the performance of graduate students. His study is based on the theory of inspiration, which forwards that a person who is inspired is likely to perform better than that one whose life is bleak. He stratified a population of 300 students into three groups and randomly selected 6 students per group. He then administered a 20-point examination to said participants, checked their papers, and recorded their scores. The results of the exam in statistics to students categorized as with spouse, with boyfriend or girlfriend, and loveless are presented below. He is to determine the arithmetic mean of scores of each of the three groups and test the hypothesis that the mean scores of at least a pair of these three groups are significantly equal, and if the difference in all the pairs is significant. This is now the result of the examination administered by Professor of Statistics. The means per group and the difference in each of the three pairs are shown in the Excel sheet. The Excel sheet in the preceding plate shows the data for the three samples, sample 1, sample 2, and sample 3, and the difference in each of the three pairs. Evidently, there is a difference between S1 and S2, between S1 and S3, and between S2 and S3. But are these three differences all significant? Customarily, the test of significance of differences in three samples is done using ANOVA. So let's apply ANOVA. Our question will be, for ANOVA, our question will be, is there a significant difference in at least a pair out of three pairs? The null hypothesis will be there is no significant difference in at least a pair. The alternative hypothesis will be there is significant difference in at least a pair. And the conditions are set here to whether accept or reject the null hypothesis and the alternative hypothesis. For the test of significance, you click Data, Data Analysis. Select ANOVA single factor. Click OK. The ANOVA single factor box pops up. Type B3 colon D8 in the input range, F1 in the output range. Click OK. The output shows the F is statistic F critical, and P. Since the p-value is less than 0.05 and even the F statistic is greater than the F critical, we reject the null hypothesis and accept the alternative hypothesis. There is significant difference in at least a pair. But is the difference in all the pairs significant? This output is not sufficient to say so. However, this result is sufficient for us to proceed to the testing of significance of each pair using t-test among others. So we can t-test the S1, S2 difference. And just the same, we have the question, the null hypothesis, the alternative hypothesis, and the condition to accept or reject the null hypothesis or the alternative hypothesis. For the t-test for the S1, S2 pair, click Data, Data Analysis, select t-test to sample, assuming equal variances. Type B2 colon B7 in array 1, C2 colon C7 in array 2, F1 for output range, and click OK. The output shows the values of T statistic, T critical, and P. Since the T statistic is greater than the T critical and even our P is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis. There is significant difference between S1 and S2. Let us t-test the S1, S3 difference. So we undergo the same procedure. And applying the same procedure, we come up with the output shown on the screen. Since the T statistic is greater than the T critical and P is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis. There is significant difference between S1 and S3. Now we test the significance of difference between S2 and S3. We undergo the same process. And the t-test output is shown on the screen. Since the T statistic is less than the T critical and our P is greater than 0.05, we accept the null hypothesis and reject the alternative hypothesis. There is no significant difference between S2 and S3. This is now the summary of the significance tests. For ANOVA, there is significant difference between at least a pair. For the t-test, for S1 and S2, there is significant difference. Between S1 and S3, there is significant difference. But between S2 and S3, there is no significant difference. The t-test shows that there is a pair which difference is not significant. So, my unsolicited advice to you students and fellow researchers, if the purpose of your study is to find out if there is a significant difference in at least a pair among the more or three pairs of participants, ANOVA alone may be okay. But if the aim of your research is to find out if there is significant difference in each of all the pairs you are studying, After learning that there is a significant difference in at least a pair from ANOVA, you need to proceed to multi-comparison tests such as Duncan's and Tucky's, or you may employ t-test. Thank you for viewing and listening.